This lesson is on solving quadratic equations. By the end of this lesson, you will be able to solve for a given variable in a quadratic equation. You will do this by continuing to factor completely. So for a warm-up, we're asked first, if a times b equals 0, then what do you know about a or b? A or b must be 0. This is known as the zero product property. Zero product property. Any number times 0 is then 0. So, what is the difference, for number 2, between an expression and an equation? Well, an equation has an equal sign, while an expression does not. Because an equation has an equal sign, equations can be solved, but expressions cannot. Expressions can be simplified. So in lessons 1 through 5 that we've worked on in class, we've been simplifying expressions when we factor. Tonight, this lesson is different because we are going to start solving. So let's remember, what is the standard form for the quadratic expression? And we have this in one of our previous notes, ax squared plus bx plus c. Well, now we're going to be looking at an equation in standard form. It's when we have an equal sign and the entire equation is set equal to 0. Okay, let's get started. It says for step 1, get the equation into standard form. Well, this equation is not in standard form. We're supposed to have it written as ax squared plus bx plus c equal to 0. So to get this to equal 0, I should add the 5 over. We now have x squared minus 11x plus 24 equals 0. Okay, next up, it says factor completely. When I factor completely, I always ask myself, is it GCF, dots, or AC method? And in this case, there is no GCF. It is definitely not dots, and I'm going to have to use the AC method. So I'm going to multiply x squared and 24. I end up with 24x squared. We could go to our calculator to record our pairs, or if we are good with our factors, we can just start listing them. I know 3x times 8x, 4x times 6x, and I believe that's it. Let's find a pair that can add or subtract to 11 in the middle. And that pair is going to be 3 and 8. But it's not just an 11 that I need. I need them to combine to a negative 11. So it's negative 3 and negative 8x. We will expand. Negative 3x, negative 8x. I have to bring down this x squared and positive 24. And the whole entire equation is still set equal to 0. I'm still not quite done factoring. I now have to group them and get a GCF from each group. So my GCF here would just be x, and I'm left with x minus 3. My GCF over here, I can divide both terms by 8, but because my leading term in the group is negative, I prefer to take out a negative 8. And then I end up with x and 24 divided by negative 8, negative 3. And this whole expression is still now equal to 0. I'm going to glue back together my factor, x minus 8 times x minus 3 must be equal to 0. So now I've taken care of step 1 and step 2. I've factored completely. Our new step. It says to make a t-chart and set each variable factor equal to 0. This is when the zero product property comes in. If A times B must equal 0, we know that either A equals 0 or B equals 0. So this is where the t chime comes from. I'm going to say that either this variable factor, x minus 8, could be 0, or this binomial factor, x minus 3, could be 0. Because whatever's here multiplied with this purple factor must equal 0. So A or B must equal 0. For step 4, we now have to solve and list the solutions in a set notation. So here I have to solve. In order to have this left factor equal 0, x must be 8. Because 8 minus 8 would be 0 times 8 minus 3 would be 5. 0 times 5 is 0. Or here, if I add 3 to solve, I get x could be 3. So my solution for this problem would be that it could be 3 or it could be 8, meaning x has two different values. And now let's check by substitution. When we check, we always rewrite the original. And now we're going to substitute and see if 3 will work. Well, 3 squared minus 11 times 3 plus 19 give us negative 5. We're unsure. If I plug in 3, I end up with 9 minus 33 plus 19. Does that give us negative 5? And it works out. Now let's substitute our other option and see if we end up with multiple answers. If I substitute in 8, we see that 8 squared minus 11 times 8 plus 19, we get 64 minus 88 plus 19 should give us negative 5, and it works out. So we have two solutions for this equation. It's x equals 3 and x equals 8. Okay, let's try it again. We need to first make sure that it's in standard form. And here I have ax squared plus bx plus c all set equal to 0. Our next step tells us to factor completely. And every time from here on out, we should be checking in this order. It will make our solutions much easier to find. There is certainly a GCF here. I can factor out 7 and then say what would be left. So if I divide each term here by 7, I'm left with r squared minus 2r plus 1. Okay, so we found a GCF. Now let's go through our checklist again. There is not another common factor. This is not a binomial with a difference of two perfect squares, but it is a trinomial, so we should try the AC method. If I multiply a with c, I get 1r squared. We haven't seen this one yet in class. 1r and 1r would multiply to give me 1r squared. But to have them add to give us negative 2r, both pieces, or both terms, should be negative. So we can expand this negative 2r to be negative 1r and negative 1r. Now we still carry down this positive 1. We carry down our r squared. And as we saw in class for lesson number 5, we can now switch to brackets, bring down our GCF, and set this whole thing equal to 0. I'm still not done factoring using the AC method. We're up to the grouping step. So now I still have 7 on the outside. And here we're going to end up with a GCF of r times r minus 1, and then a GCF of negative 1, since the leading coefficient of the first term is negative. Left with r, and then 1 divided by negative 1 is minus 1. I can close my brackets and set the entire equation equal to 0. All right, our last step from factoring is to rewrite as the product of two binomials with our GCF factor out in front. So I have this all set equal to 0. According to our steps from before, if I go through, we've factored completely. Now it's time for our t-chart. Let's try it. It's tea time. I draw the t-chart, but if I read it carefully, it says to set each variable factor equal to 0. Now, there are three factors here: 7, this binomial, and this binomial. 7 is not a variable factor, so I do not have to set it equal to 0. Even if I tried, does 7 ever equal 0? No, so that is not part of our solution. But instead, I'll have r minus 1 equal to 0 and r minus 1 equal to 0. Our next step states we have to solve for each, and here we'll see we get the same solution both times. So now I believe the solution will just be when r is 1. To do a quick check, we should substitute into the original problem. So let's do a check. 7 times 1 squared minus 14 times 1 plus 7. I wrote 17 up here. Let's fix that. Should give us 0. Let's try it out. 1 squared is 1 times 7 minus 14 plus 7 should give us 0. This gives us negative 7 plus 7, and it works out. So our solution is just 1. Okay, first step, we need to check to see if this is written in standard form, and it is not. So first, we need to get rid of this 2d and move it over to the other side. 2d minus 2d will combine to turn it to 0. And I line it up with the 7d because those are like terms. So now I'll have a new equation, 2d squared plus 5d minus 12 set equal to 0. Okay, at this point, I'd like for you to pause the video and try it on your own. And then press play to check your answer. Okay, let's see how you're doing so far. When you multiply using the a and c term, we find that the product is negative 24d squared. We choose negative 3d plus 8d to combine to positive 5d, and we factor all the way through. The final factoring step should look like this one, or you could have 2d minus 3 first, followed by d plus 4. But we're up to the t times step, where we take each variable factor and we set them equal to 0, because this side could be 0. 0 times anything would give a 0, or this side could be 0. So 2d minus 3 could equal 0. Now, we must subtract 4 from both sides, and I find d could be negative 4. Here we have to solve as well, not as obvious, but 2d could be 3. When I divide by 2, d could be 1.5, or 1.5. So our solution set here is negative 4, or 1.5. You could also write your solution as negative 4, or 3/2. Okay. Now before moving on, we should always check our solution. I'm going to move this, make some room. Let's check. 2d squared plus 7d minus 12 equals 2d. So 2 times negative 4 squared plus 7 times negative 4 minus 12 should equal 2 times negative 4. Everywhere you see a d, you should replace it with the solution to find if it's true. So 2 times 16 plus, rather, it's minus 28 minus 12. Does that equal negative 8? So 32 minus 28 minus 12, does that equal negative 8? And it does. Now I would check again, but this time for our other solution, 3/2. To check this solution, I suggest you use your calculator and you type in the fraction inside parentheses, and it will work out. At the end of this lesson, we've arrived. We should be able to solve for a given variable in a quadratic equation. We'll continue to use our steps by factoring completely. We'll practice this again tomorrow in class.